approximately 779 with 63.63. So we could round this and say that the time or the years of the table, the age of the table, will be 780 years old. And so, because of that, we will say that it could not have belonged to King Arthur. So, last problem of this section. Another application of logarithmic functions is the Richter scale used to measure the intensity of an earthquake. So the scale is uses logarithm base 10. Remember, if you do not see the number, you assume right away that it is a 10. So in this case, the I sub 0 that we see here is going to be an earthquake of an intensity that is called zero earthquake. And it is a smallest detectable earthquake, kind of like a control group. Imagine it like that. So something that another earthquake is going to be compared to determine how intense this was. And the Richter scale, I'm not sure if it starts at 0. I doubt it. I think it might start at 1. And it goes up to 10. And so, for example, an earthquake of 9.1 is it will be intense, like the one that the problem is mentioning here in 2004. And it was the tsunami, the underwater earthquake that caused the disastrous 2004 tsunami in Southeast Asia, measured 9.1 on the Richter scale. So here, just I by itself, it means it stands for the intensity of the ground motion of the earthquake. So the first question here says, how did the ground motion of the tsunami compare with that of the zero earthquake? So in this case, we can compare, I'm going to use R for the output of the function. So the Richter scale, so R of I is equal to 9.1, which is what we have here. By the way, we will be using this formula. Now, if I take this side of the formula, the right side, because here I'm saying that R of I is equal to the right side, so I could say the log, common log, because it's base 10, of the intensity divided by the intensity of the zero earthquake is equal to 9.1. So if we change this expression into an exponential expression, remember we do start with the base, and so this will be 10 to the power 9.1 is equal to this part right here, I divided by I sub 0. Or if we solve for I, because that was a question, we could say that I is equal to 10 to the power 9.1, and this I sub 0 is dividing to I, so it would take that across, it will be multiplying, so I sub 0. So to answer the question, we could say that the intensity of that earthquake was 10 to the power 9.1, more intense as a zero earthquake. Now, 10 to the power 9.1 is approximately 1.26 billion. So we could say that compared to a zero earthquake, an earthquake that is barely detectable, the one that has a 9.1 intensity on our Richter scale, it will feel 1.26 billion times more intense. And for the last question, it just says that what is the Richter scale, the intensity of an earthquake with 10 times as much ground intensity. So for this new earthquake, not the one that happened in 2004, we want it just to be 10 times more intense. So it will be 10 times what we got on the previous question. 10 to the power 9.1 times I sub 0. And so from here, we could use the associative property here and add the exponents of 10. So we will get 10 to the power 10.1 times I sub 0. So from here, we could take that expression and convert it back to a logarithmic expression. And here I'm missing I sub 0. And so this will be the log of, instead of being log of I over I sub 0, we're going to replace this I with what we got here. So it will be 10 to the power 10.1 I sub 0 divided by I sub 0. This 2 will cancel out, and we will get log of 10 to the power 10.1. So if we take that and use that rule that we learned last class, that this is base 10, we can cancel this, and the answer will be